Let's now look at products. We will first look at the distributive law. So, first example, expand each of the following. We have 2 into x plus 1. Now, the distributive law means the value outside the bracket, which is 2, needs to be multiplied by each of the values that are inside the bracket. So there are 2 terms inside the bracket. It's x plus 1. So it's x and positive 1. So we need to multiply the 2 by the first term inside the bracket, which is x. So that will become 2 times x. Then we need to multiply the 2 outside the bracket by the second term inside the bracket, which is positive 1. So that will become 2 times 1. And because there's the plus sign in the middle there, that's going to be a plus sign as well. So 2 times x will give me 2x. And 2 times 1 will give me 2. And I bring down my positive sign, which is here. So 2 into x plus 1 is expanded to become 2x plus 2. So also to remember in algebra that x is the same as x to the power 1. So those two terms can be written interchangeably. Let's look at now binomial times binomial. When you have a binomial, which is 2 terms, and you're multiplying it by another 2 terms, you need to use the FOIL method to calculate. So the FOIL method, FOIL stands for first, outer, inner, and last. So let's use this for the first example. Here, expand each of the following: x plus 3 times x plus 5. So x plus 3 is a binomial, and you're multiplying it by x plus 5, which is also a binomial. So this is definitely a binomial times a binomial, and it's a case where you use the FOIL method. So the FOIL method, f first is first times first. So x is in the first bracket here, and the first one in the second bracket is also x. So x times x is first times first. That's my f from FOIL. Then my O now is the outer values. So the outer values is my first term there, which is x, and my last term here, which is 5. So that will become x times 5. There we go, or 5 times x is the same thing. Now we look at I, which is inner. The inner values are positive 3 there and positive x there. Those are the 2 inside values in my question here. So positive 3 times x. There we go. That's my I. Now we look at L in FOIL, which stands for last. So we're looking at the last term in the first bracket, which is positive 3. And the last term in the second bracket, which is positive 5. So L there will stand for positive 3 times positive 5. There we go. So we have our F, our O, our I, and our L. Now we can simplify. So first one, x times x is x squared. 5 times x is 5x. 3 times x is 3x. 3 times 5 is 15. You just need to check all your signs, like the rules for integers that we went over when we did integers. So now we need to put all our like terms together. We've done this previously. So our first term is x squared. There are no other x squared terms here, so that will remain as x squared. My second term is 5x. Is there another x term? Yes, it's positive 3x. So we put those 2 terms together. So positive 5x plus positive 3x is positive 8x. And 15 here, there's no other constant around, so 15 will stay as 15. So my final answer then will be x squared plus 8x plus 4. Okay, let's look at the difference of 2 squares. You can use this method when both binomials are exactly the same, except that one is a plus sign and one is a minus sign. So for the difference of 2 squares, there's an example here. this is difference of two squares, x plus 2 times x minus 2. The only difference is that one is a plus, one is a minus. Except for that, everything else is the same in both brackets. So let's work with the example here. Expand each of the following. We have x plus 3 times x minus 3. Difference of two squares is really easy. All you do here is it's first times first and last times last. So the first one in the first bracket is x, the first one in the second bracket is x. So x times x gives me my x squared. Now I need to do my last times last. My last term here in the first bracket is positive 3, and my last term in the second bracket is negative 3. So positive 3 times negative 3 is negative 9. So x plus 3 times x minus 3 can be simplified to x squared minus 9. Let's look at squaring a binomial. So let's expand each of the following here. Squaring a binomial. So we have a binomial that's given. Remember, a binomial is two terms, in this case x plus 5. And when the entire bracket is being squared, as shown there, you're going to use this method here to square the binomial. So you're going to say first times first. Here we go, x times x. Then you're going to leave a space and you're going to work with last times last. Positive 5 times positive 5. There we go there. Now for the middle term, this is where it gets a bit tricky, but it's not too bad. For the middle term, you need to multiply the first term times the last term. The first term is x, the last term is 5. X times 5, there we go. And you're going to double this to give us the middle term. So x times x is x squared. Our middle term is 2 times 5 times x, which is 10x. And our last term is 5 times 5, which is 25. So that becomes x squared plus 10x plus 25.